Hello again, this is Dr. James Camp from Lee College in Baytown, Texas, and this is my commentary on Chapter 5 of Big C++ by K. Horstmann. The topic we're going to be talking about today is functions. In Part 1, we're going to talk about implementing functions, parameter passing, function components, and in Part 2, the next lecture, we'll talk about strategies for composing functions, the scope of variables, and value and reference parameters. So what is a function? Okay, a function is a sequence of instructions that's been given a name. A function packages a computation neatly into a form that can be easily reused from one main program to another, or even from one function to another. There are two ways to understand functions in C++. One is the mathematical analogy. Okay, if we say f is a function in math, that means y is equal to f of x, where f takes x as some kind of input and returns y as an output. Maybe f of x is x squared, or maybe it's x cubed plus x squared plus 2x plus 1, or something like that. But it returns a different y depending on what f is. There's also a computational definition, a computer science definition, in which f is sort of a package subroutine. Okay, if your whole program is a routine of code, then you can package out a subroutine, a smaller piece that takes care of one specific task, so your main program doesn't have to contain all of that code. And we'll see a couple of examples today in this presentation of where code looks simpler when you've excerpted out a piece of a subroutine. Okay, so why write functions? Your main program becomes less cluttered and gets easier to read. Imagine, for example, you're writing a program that controls a robot. Writing one reference to the function forward and then another reference to the function stop is a lot easier than reading a series of commands to the individual motors that make up the robot over and over and over again throughout your code. Each specific task or job has its own piece of code, okay? And you can write, debug, and maintain each of those functions separately. We'll take that to an even greater extent when we learn about object-oriented programming in Unit 2. Code that gets used more than once only has to be written once, debugged once, maintained once, okay? You don't have to write every function in the C++ standard library because it's already been written for you. Okay, one expert in computer science got to write that function once and debug it once, and they maintain it every time an update to the C++ standard library is made. Okay, and as with the C++ standard library functions, functions that you write can be reused between programs that need similar jobs done. So if you write a program, a function that takes input and makes sure that that it's a numerical input between 0 and 10, and you do that a lot, well, you can drop that function into every program that you write. There's no need to reinvent the wheel every time you write a new program. Okay. So you've already used functions to get jobs done in the context of programs that do math. For example, we're going to use the function pow from the CMath library. The pow function has already been written for you, okay, by the expert computer scientists who put together the C++ and before that the C standard library. Okay. You don't have to know how pow works. chances are it's not as simple and straightforward as you think it is, because it's got to be able to calculate fractional powers and square roots and things like that in addition to just x squared. So it's probably got a fairly complicated structure to it. But we don't need to know what the internal structure of POW is. What we need to know is that it takes two inputs and it produces one output. How did that work? How did 2, 3 turn into 8? We don't need to know that. What we need to know is that the function has a certain specification that promises us that if we pass it a 2, 3, we're going to get an 8 as a result. Okay, what is that specification? For POW, the specification is double POW, double base, double exponent. This is copied from C++.com, which has a list of specifications for all the CMath functions. Black boxes have inputs and outputs. Okay, black boxes are an engineering concept that when you're designing complicated devices, you make the smaller parts of them black boxes that just have inputs and outputs, and then you go in and design those later, or you task out the design of those smaller parts to other engineers. The inputs to a function are called parameters. Okay, they're supplied in parentheses after the function name, and for POW they are base and exponent, both double type parameters. The output of a function is called its return value. Okay, for POW the return type is double, and you can see that's the red keyword that comes before the word POW in the function specification. We say that a program calls a function when it wants a particular job performed. Okay, if int main calls POW 2, 3 and sets the result equal to, or sets z equal to the result, then we know main is calling the POW function and asking it to compute 2 to the third. The way this works is that the main function is actually temporarily suspended in the computer, and control is passed to the POW function. Okay, POW is given the parameters 2 and 3, and it's allowed to do its work, and then the POW function returns its result back to main, and main resumes execution by assigning the result to the variable z. Here's another way to look at this. There are kind of two threads of execution going on in this flowchart, separated by the double line, where the main thread passes 2 and 3 to POW and then waits for POW to compute its answer and return the result, or pass it back to the calling function, at which point POW ceases to exist and main stops waiting and catches the result from POW and uses that result in some way. Okay. When another function calls POW, it is required to provide values for any of the parameters that POW asks for. You can't just say POW in parentheses and let it go, because it doesn't know which two numbers you're trying to work on, which number is the base and which number is the exponent. Okay. We don't call that input because we want to avoid confusion with CN, okay, the user input. So providing input to a function is called passing arguments to that function. So in the code displayed at the top of the screen here, POW 2, 3, 2 and 3 are said to be arguments to the function POW. Okay. Many functions, not all, return a value to the calling function. Okay. In this case, the computed value of 2 to the third is going to be returned, and it's going to, the equals sign here means that that value is going to be assigned to the variable z. Okay. Now, somewhat confusingly, functions can also ask the user for input using cin and print values to the console using cout. So why not just always have them do that? Well, here's an example of where the two different kinds of input and output come in handy. Consider a mobile banking app. Let's say the user selects search from the main menu. The main program will now call the search function. The search function might take the current account number as an argument or a parameter. Okay. It takes it as a parameter. It's passed as an argument. That's somewhat confusing language, I understand. So the search function might take the current account number as a parameter, and so when the main program calls search, it's going to pass the current account number as an argument. The same function, however, might take input from the user because we haven't told it what to search for yet. So it might get line cin search phrase, and the user types rent payment or something like that. Well, usually you don't write rent payment on your check. You write your landlord's name or something, but whatever. Similarly, return does not equal output. Okay, that mobile banking search function might want to display output to the user, so it would say cout first search result. Okay, but the function might also want to return a value to the function that called it, such as telling it how many results had been found. Okay. A return statement doesn't display any output. It's just communicating with the calling function. And similarly, an output statement, using cout, for example, does not send a value back to the calling function. It only communicates with the user. So you have two different communications that a function can do. It can communicate with its calling function, and it can communicate directly with the user. Okay, I hope that didn't confuse you there at the end. Now, let's talk about writing your own functions. The process starts by identifying a common operation that could be handled by a function, such as calculate the volume of a cube. We then write out a function definition. When defining this function, okay, you're going to need, in red, to pick a good descriptive name for the function. Cube underscore volume is a pretty good description of what this function is going to do. Give a type and a name for each parameter. Now, for a cube, we only need to know one side, so we only have one parameter, double side length. You can have one parameter, two parameters, three parameters. You can have as many parameters as you want in a function. You can even have functions with no parameters if that function, say, always does the same thing, no matter what the context is. For example, my robot function that I mentioned earlier that says stop probably wouldn't take any parameters. It would just cause the robot to stop no matter what else was going on in the program. And you can specify the type of the return value. In this case, we're calculating a volume, which could quite easily be a floating point number, so we're going to make the type of the return value double. Finally, we write the body of the function as statements enclosed in curly braces. Okay, we create a double volume equals pow side length 3. Okay, we're going to cube the side length, and then we're going to return that new value volume that we just calculated. Unlike ifs or loops, however, the curly braces in this case are required. Finally, it is possible to document your function using what's called a Java doc style comment or a function documentation comment. This starts with a /** instead of the usual /* for a multi-line comment. This came from the development of Java, which you may know is a competing programming language with C++. The developers of Java wanted to be able to easily and automatically create documentation for their code. So they created this function comment style that you start with the /**. You have a single line that defines the purpose of the function, and then you have an @param line for every parameter that the function takes, and an @return line to define the return value of the function if it has one. Once you've written your functions, it is good form to test them. Okay, so we write code that in our main function that calls the function we just wrote, and this is what's called a unit test main. It's not really a separate program that does anything useful in itself. It just creates a cube of size 2 and a cube of size 10 and figures out what their volumes are, which we expect to be 8 and 1,000. All right, now let's get into some of the nitty-gritty of how functions work. When a function is called, a parameter variable is created inside that function for each value passed in. Each parameter value is initialized with the corresponding argument from the function call. So low is created and initialized with value 1. High is created and initialized with value 12. Let's see how this works with a call to the cube volume function. We're going to keep up with these variables and parameters, result1, side length, and volume. When the calling function first calls cube volume, there is no value for result1 yet, and there's no value for side length yet. As it processes cube volume, it finds the argument 2 and passes that to the cube volume function. Cube volume creates the side length variable and assigns it value 2. Cube length then, or cube volume then creates a variable called volume and assigns it the value of side length times side length times side length, which is 8. Okay. It's then going to return that value, which is going to be caught by the calling function and assigned to the variable result1. Okay. At this point, the function cube volume ceases to exist anymore, and so side length and volume both disappear from memory. What about return values? The return statement ends the function and returns a value to the calling function. Okay, so we can use return statements to end the function early, short circuit the function in a way, if we find something that's an error or something that is a special condition that we want to handle separately. So for example, if the side length were negative, there's no point in going on and calculating the volume of a cube that has a negative side length, so we'll just return 0 and end our function early. Okay. Return statements can also return any expression. There's no need to actually create a variable and then return that variable. So we can eliminate the extra variable and just return the expression, return side length times side length times side length. A common error, however, is to have an if statement in your function that returns something, but what about if not? What is returned if side length is not greater than or equal to 0. In this case, there would not be something that would return, and that would cause an error in your program. I'm not sure in C++ if that would be a compiler error or a runtime error, but it would certainly be an error. Okay. It's also an error to call a function that the compiler does not know, okay, just like using an undefined variable. And the program is compiled from top to bottom. There's no first pass through to catch all of the names, and then we go through and compile. So we need to define all of our functions before they are first used. Okay, but sometimes that's not possible because one function might call another function, and then that function might call the first function. Okay, sometimes functions call each other back and forward. So some programmers prefer to prototype or declare each function at the top of their program and then write the complete function at the bottom of their program. Okay, a prototype in C++ is just the function header line followed by a semicolon. Okay, and you can even simplify it beyond that because the parameter names are optional in a prototype. So you could write it as double cube volume double. I don't like that style because I want to see in my prototypes what the meaning of each of those parameters is going to be. So here's probably better style is we declare the cube volume, double side length, semicolon. Then we write the main function, and then at the bottom of the code we define cube volume. Notice that we don't put a semicolon at the end of it this time. We do put the curly braces and the code that returns the cube of side length. So if you're going to write your own function, there are a few steps that you're ultimately going to take. You're going to describe what the function should do. You're going to determine the function's inputs. Okay, computing the volume of a pyramid needs height and base side length, so those are going to become our parameters. You're going to analyze the types of the parameters. Height and base length might be fractions or decimals, so we'll create both of those as doubles. And you're going to examine the type of the return value. Well, if we have fractional height and fractional base length, we might end up with fractional volume. So the return type should also be a double. Finally, you're going to write pseudocode for obtaining the desired result. Okay. Volume equals 1/3 times height times base length, and then you translate that into a function body. In this case, they decided to break it up into a base area calculation and then a height times base area over 3. Notice that they didn't put 1/3 at the beginning because that would be doing integer division and you would get a 0. So putting height times base area divided by 3 is a much better way to write that. Okay. Finally, you test your function by writing a main function that calls pyramid volume a couple of different ways and test for boundary cases like 0 height. Finally, for part 1 of this lecture, we're going to talk about functions without return values. So far, we've considered functions only in the mathematical sense, okay, that they take an input, they transform the input in some way, and they return an output. But, as I said at the beginning of this lecture, there's another way to think about C++ functions as subroutines that take a complex bit of coding out of your main function. Code in a function can be reused in other programs, so that's one reason to take that complex bit of code out of your main function, and it can be written, debugged, and maintained easier. Okay. And moving code to a function makes your main code easier to read, as again with my example with the robot, where it's much easier to read, while forward sensor is not blocked, go forward at speed 50. Okay, go forward at speed 50 is much easier to read than set the value of several different motors and make them do their jobs. So we'd have to write that code somewhere, but we'll write it in a function called go forward, and that makes the main code much easier to read. Consider the task of writing a string with a box around it. Okay, any string could be used. For example, the string hello would produce hello with a little box of dashed lines around it. Okay. If we encapsulate this function, this set of code to write that box in a function, it's not going to return a value. It's just going to print the requested output on the screen. That kind of function is called a void function because we use the keyword void as a indicator that there's no return value. Void functions are used to simply perform a sequence of instructions without returning a value to the calling function. Here's what that box string would look like. Okay, it's a void function. It takes a string as a parameter. It finds the length of the string, and then for I equals 0 to n plus 2, we output dashes, then we output a vertical line and the string and another vertical line, and then again from I equals 0 to n plus 2, we output dashes. Note, this function is not a mathematical function. It does not compute any value. It is a subroutine type function. It performs some actions and then returns to the caller without returning a value. Also notice that the return here is implied by reaching the end of the code block. We don't have to specifically say return at the end of the function. Because there is no return value, you cannot use box string in an expression. Okay, you can say box string quote hello. You can't say result equals box string quote hello, or cout box string quote hello. Okay, because box string doesn't return any result. We can use a return statement without a value if we want to exit the function early. Okay, just as we said return 0 if the side of a triangle was negative or something like that. We can say if the length of our string is 0, just return. There's no need to print anything. We've been given an empty string. All right. That brings us to the end of function basics, lecture 1 of 2 on functions. This is a good time to take a break and write some functions. Specifically, the function I'd like you to write right now, or there are 2 functions I want you to write right now. One is a mathematical style function, a function that does return a value. Okay, so it'll be double triangle area of double side or something like that. Okay, and the other is a void function that prints a 45, 45, 90 triangle to the screen as shown in the upper corner here. We've printed this triangle here. Okay. You're going to let the user enter a triangle size. In this case, the size would be 4 for my sample output there. You're going to call your first function, the one that calculates the area, and pass the result to cout. So you're going to say triangle area equals and the result of your function. And then you're going to call your second function and let it do its thing. Let it print the size of that triangle to the screen. All right. Hope this isn't too difficult for you as for a program that writes your first writing your first functions of your own. And I can't wait to see what you come up with. So for now, until the next lecture, good luck and happy programming.